So next we'll take a look of how we can work a little bit more efficiently in R with scripts. And I'll show you the basic setup for both Windows and Mac computers. So let's start with the setup in Windows. If you are programming, you are considered a power user. And for that, you actually need to know where your files are actually located. And Windows kind of hides this by default from you, just to make life easy. But if you haven't done so already, go to View, then Navigation pane, and first check this navigation pane. So this will actually give you some idea on the left side here where your files may be. But if you go to any of the libraries, it still doesn't exactly tell you where the files are. So there's some other things that you can check. So you go again to the View button, to the navigation pane, expand to open folders, and then do this one more time, navigation pane, and show all folders. So once you have that, and you click on documents, and let's say you go somewhere in here. So as you move into your directories, this expands automatically, so you always know where you are. Okay, let's go to our USB drive. So you can work on a USB drive, for example. And there's one more thing that Windows hides from you, and those are the file extensions. But we also need to know what those are. Otherwise, you run into all kinds of problems. So again, go to View and check File Name Extensions. And you see they now appear here. So we have R scripts, we have CSV formatted files, and there's also a DBF file that is part of the download for the first lab. So now you always know where you are on the left side here, and you know what kind of files you're dealing with. And with that, you can start programming. Now, the way things work in macOS are almost identical to Windows, and I don't want to explain everything twice. So what I'm going to do is I first walk you through how to actually use it in Windows, and at the end of the video, there'll be a short section on what's done slightly differently when you use R on the Mac operating system. So just start by watching the Windows tutorial, and then there are a few modifiers in the end for macOS. In this video, I'm going to explain to you how to work a little bit more efficiently in R. So I show you how to make a shortcut to start the program, how to use script windows, and how to import data files in CSV format, so comma-separated value files. So if you open R like this in Windows, you have this console, which we already discussed, but you also have this GUI, graphical user interface. So these are the menus here and the buttons. So what I'm going to show you may seem a little convoluted at first, but you'll see the power of this in a minute or two. After you open this, the first thing you do is you're going to save your workspace. So you go to File, Save Workspace, and we're going to call this Start R, and make sure that this R data extension is still visible there. So I'm going to hit Save. And what this does, it saves this shortcut here, start R data, in a little folder that I previously made here under my documents, lab 1. So this has the advantage that if you start R here instead of from the start menu, it remembers where your workspace is and where your current directory is. So the current directory is where the shortcut resides. So if it's in lab 1, that's what's automatically gets set as the current directory. So in order for this to take effect, we have to actually close R, close it, and so we ignore this. We have already saved our workspace image, and now we're going to restart it by double-clicking Start R. So there it is. And now what we can do is we can open a script window, so let's say New Script, and we can put a few commands in here, maybe just the same that we've written before, 2 plus 3, A equals 2 plus 3. You can also do it like this. A equals 2 plus 3. So we're going to save this script. We have to make sure that this is highlighted. And then you go to File, Save As, and then we see it automatically now defaults to my lab 1 folder. I can save it as script 1, and I give it the extension R as it is suggested here, so that R recognizes it as a script. But it really is just a text file. So if we look at it here in our folder, I can actually open this with Notepad, for example, or with another default program. So you just pick one you like, some sort of text editor, and make sure always select that program. So let's choose WordPad, And there it is. So it's just plain text files. Good. So now let's, just for the fun of it, let's close R again. We don't want to save our workspace image. So we can now very quickly get R underway and execute a script. I show you how to do this. So we double click this one and we click Open Script. And there's our script 1. Now there are two ways to do this. One is to highlight something and then let me resize this here. And then clicking this run command here, run line or selection. And you see it essentially copies and pastes this over here and you get your answer. The other way to do it is you can place your cursor anywhere in a line and you just hit Control R. Let me just put that on-screen keyboard up. So you hold Control and type R, and see this has been copied over, and I can type, I keep holding Control and I just type R again and it executes the next command. So that's an interesting command that I haven't shown you before. So if you want to assign a number to a variable, but you also want to see what it is, you can put this in brackets. So it doesn't just give you nothing in reply, but it also gives you the number that has been assigned. So let's do something different. Let's actually import some data and do some basic statistical analysis. And for this I've actually created a little spreadsheet here in Excel, and I saved it here as lab1 XLS. So this is probably how you enter your data in Excel. It's very convenient. And you recognize I entered the same numbers here that we had in the last video. And the best way to import it into R is actually in the format of a CSV file. So after you enter your data, you just save it as a CSV file. It's right here. So it defaults to lab1, which is fine. It gives us a bunch of warning message, and we can close this. And you see now we have two files. So CSV has the advantage it's plain text. So we can actually change this extension here. And you see it's just a plain text file. Let's change this back to a CSV file. And those plain text files are most reliably imported into R. So let's bring back R. And the command to import things goes like this. .1, so this is our data object, is read.csv. And you actually have to put this in quotation marks. We call this lab1.csv. So let's execute this with Control R. Something's wrong. So that's actually another interesting error. We don't actually get an error message, but after we executed this, we get this plus sign here. And that means that R is waiting for something. You know, the command is not complete. And so what I forgot here is to put a quotation mark to close this. And you're actually stuck. You can't do anything. So you have to hit the stop sign here. So now you get your command back. And we can now put this quotation mark here. And I hit Control R again. And now it probably executed that. So now just to confirm that this imported right, we probably want to look at our data. And you can do this by highlighting the .1 only, and then again you hit Control R and it shows us our data set. So this works for small data sets. If you have a big one, another way you can check it is you just look at the first 6 lines of your data set. So the command for this is head of .1, which in this case gives us the same result. You can also bring it up in form of an editable Excel spreadsheet. So the command for this is fix .1. So you could actually add data here interactively, although I don't recommend that. So let's close this. So one thing you might think you can do is to look at a variable, any of those X or Y. So we could type X here and execute it, but it says that object is not found. So if you import your data via a table, you actually have to type the table name, .1, and then a $sign, and then your variable name. And there you go, there's your vector of numbers that belong to variable X. If you want to save yourself that typing effort, another thing that you can do is actually attach your data set. So it's an attach command for .1. That means if you're looking for a variable, if you're typing a variable, by default it would look in that .1 data set. So now if we attach it first and Control R again to look at X, now it actually finds it. So not the same problem that we had before. So we can also look at our data. Why don't we do a box plot of .1, and it shows us a distribution of the variables x and y. X goes from 1 to 7 and the other one goes from 4 to 9. So that's a nice graphical representation, and we can do our t-test that we've done before of x, y, and let's execute this with Control R, and we get the same result. So although the means were different, this is not a statistically significant difference if x and y were samples. Okay, so this is the basic setup. Let's save our code. So in order to save it, you just click this frame, you hit the save button, and we're done. So let's close R, and it asks me to save the workspace image, but we never do this. So just say no to that. And this is it. So now you're really in a position that you can very quickly open something up, run some analysis. So the basic setup is like this. You have your start command, your script, your raw data, and your CSV file all in one folder. You double click R to start it. You hit the open button, pick your script, place your cursor in the first line, and then you can just hit Control R and work your way through this. Control R, we attach it, we get our box plot, and we get our statistical analysis. All done in 10 seconds. So this is how you can very efficiently work with this program. Okay, I'm also going to show you how to run the R-based programming environment on macOS. So download the latest R version that matches your macOS. So then you install the package. You also need to install Xquartz, that's for the graphics. And also install R tools. We'll need that at the end of the first lab. So if you start R, you have the basic console window, and you can do exactly the same as I've shown you in Windows. So you can enter commands right here. But obviously we want to work with the script window, so you can just open the script window here and enter your commands in that script window. And you execute it with Command Enter, and it does the same thing. So it sends it to the console and executes it. Now, Command Enter doesn't put the cursor in the next line, so if you want to work your way through code, you have to use either the mouse and place your cursor in the next row, or you just push the down key to go to the next row. You can also highlight sections and hit Command Enter, and that sends a whole bunch of lines. Now, the first thing you usually want to do is save this script. So I'm just going to push save, and I'm just calling this nothing. It's just a test. And use the extension .r. So you can put it on a memory stick and use it on a Windows computer in your lab, so this will work perfectly fine. And now you want to navigate to a folder where you're going to work. So R lab 1, I already made that up under my documents. We're going to hit save, and we can close all this. So again, just like in Windows, you don't want to work with R without having set the working directory. So we don't want to save our workspace. We never do this. We don't worry about that. And now I can actually go to my file manager, and there is my nothing script. Now I've already written another script here that has something in it. And so starting it, so you don't actually need a shortcut like we use in Windows. You can just double click the script here, and it opens R. And you can see the working directory here is set to documents R lab 1. So let's see if everything works. I downloaded the files from the lab 1, so there's an Aspen CSV file, there's a database format that nobody knows what it is, and we have our script file all in the same folder. So if I execute the aspen.csv, it should find it because we're automatically in the correct working directory. So let's hit Command Enter. That's good. Skip a line down, We can take a look at the head. There it is. We can attach it. We can plot dBH over volume here. That seems to work fine. We can maybe run a Pearson correlation here. It gives me a correlation of 0.99 with a highly significant relationship, obviously. And last but not least, I want to show you how to add a package. So you can use the package installer here. And you get your list. And we can search for foreign. There it is. Install selected. That's done. And now we should be able to execute the library command. So we call that library. That works, and hopefully we can now read our Aspen DBF that we had in the lab. And we can just look at the head again, and it's there. So everything works just as easily in macOS. And you even got a little bit of color coding in your script editor. But if you want something fancier, feel free to try out RStudio. So if you're not confused by it, then use it. But as I said before, for this course, and I would say for your entire scientific career, this setup will work beautifully. Unless you really become an R programmer who develops, complex functional models, then maybe a slightly fancier programming environment will help you.